Question 12. Ladies' Home Journal magazine reported that 66% of all dog owners greet their dog before greeting their spouse or children when they return home at the end of the workday. Assume that this claim is true. Suppose 12 dog owners are selected at random. Let X equal the number of owners who greet their dog first. Okay. Part A. Explain why it is reasonable to use the binomial distribution for probability calculations involving X. Okay, so let's just go through the four conditions. Okay, are the outcomes binary? Well, sure, a success is an owner who greets the dog first, and a failure is an owner who greets their spouse or child first. Okay. All right. I, independent trials. All right, so let's put a check there. The outcomes are binary. Okay, are the trials independent? Well, since the owners are selected at random, the behavior of the first owner is not going to influence the behavior of the second owner. They don't know each other. They're two completely random people. So yes, this is safe to assume. Let's write a better response. Each owner's behavior does not affect the behavior of other owners. Check. All right, N stands for number of trials fixed. And this is true. They surveyed 12 dog owners. Not 10, not 11, not 13, but 12. All right, the last condition, S, is for same probability of success, which we're assuming this is true, that it's 66%. All right, so since all four conditions are met, then we know this random variable is going to have a binomial distribution. All right, let's move on to part B. Find the probability that exactly 6 owners greet their dogs first. So, in other words, what's the probability that X is equal to 6? Okay. All right, now there's a formula for calculating binomial probabilities. Here it is on the formula sheet. It looks a little different than how we wrote it in class. Okay, so the first term or factor, it looks like a fraction, like n over x. We wrote it as like, I don't even know if we used x. I think we did like nck. Right, it's just the number of ways of getting so many successes and so many failures. The last two parts are the same, right? So this middle piece, p of x, that's the probability of your successes. And the last term, the 1 minus p to the n minus x, that's the probability of all your failures. Okay. I'm going to go ahead and write it how we did in class. So I think it would have been, so nck times p to the k times 1 minus p to the n minus k. Right, so in this context, n is 12 and k is 6. All right, so this is going to be 12 choose 6. Oh, and p is 0.66. 0.66 to the 6th power and 1 minus 0.66 to the 12 minus 6th power. Okay. All right. Now we could go and type this into the calculator. It's a little tricky. You just have to know where to find the combination function. You can just find it in the catalog. I think it's also under math. Okay, but it's a lot easier to just use the binom PDF command on the calculator. Okay. All right, so this command first asks for the number of trials, so we know that's 12. The probability of success, which we know is 0.66, and then the value, the boundary value, which in this case is 6. Okay. All right, so 12, 66%, and 6. Okay, and we get an answer of 0.118. Okay, so almost 12%. Part C. In fact, only 4 of the owners in the sample greeted their dogs first. Does this give convincing evidence against the lady's home journal claim? In other words, calculate the probability that x is less than or equal to 4, and then use the result to support your answer. All right, so the probability that x is less than or equal to 4, we could use the binom CDF command. Right, this will give you the probability of at most a certain value. In this case, that value is 4. Okay, binom CDF. All right, so we still need to input the number of trials. That's still 12. The probability of success, that's still 0.66. And now the boundary value, which is at most 4. So x is 4. Okay, 12.66, 4. All right, so the calculator gives the following probability: 0.0213. Okay. All right, so the calculation is done. Now we need to answer the question, is this convincing evidence? Okay. Well, think of it this way. Is this result statistically significant? And it is, right? Anything that's less than 5% is statistically significant. Okay. In other words, yes, this result would give us convincing evidence against the magazine claim. All right, so